To start, I'd like everyone to take a couple seconds and think of something useful. It can be useful to you or just a general piece of utility, and just call it out. That person right there, that's a great answer, my friend. It's okay. So, I also have the same answer. For me, electricity is such a useful utility. And what is electricity? Well, in its most basic form, it's a source of energy, the currency of our world. Now, energy can come in many different forms, just like fire, steam, and fission. These three phenomena marked monumental leaps in energy production, from cavemen banging rocks together to the steam engine kick-starting the Industrial Revolution and the hum of nuclear power plants in our modern-day world, each of them redefining energy. Each of these leaps have shaped the course of humanity for many years. They have influenced our present in both profoundly beneficial ways and at times with detrimental consequences, as we've sadly seen with nuclear power. Now, I'd like to take a minute and talk about our sun, the light of our lives, quite literally. It's been shining and exploding up in our skies for billions of years, pouring out a seemingly inexhaustible amount of energy. But where does this energy come from? Where does this vast reservoir of energy come? Well, deep inside the sun's core, there's a never-ending process called nuclear fusion, the invisible dance of molecules that power our sun. At its heart, fusion is a process of taking two hydrogen particles and combining them to form something new. Think of it like taking two puzzle pieces and joining them together to form a part of a picture. Now, this explanation sounds very simple, but in reality, getting these two particles to join is a lot harder. Why? Well, to answer that question, I'd like you guys to visualize these particles as magnets. Now, as many of us know, when we put two magnets together, they can either repel or attract. This same repulsion force happens in particles. So then, how do we get them to touch? How do we get them to fuse? Well, think back to those magnets. If you were to push hard enough, you could overcome this repulsion force and get them to touch. Well, you could do the same with particles. But instead of using force, we get them to move faster, fast enough so that they smash together, overcoming this repulsion force. Now, our sun is really good at physics and can naturally do this process. Due to its immense size, it creates an intense pressure on its core, which heats up the hydrogen particles inside it, making it move faster and faster, making them smash together and overcome this repulsion force we're talking about. Once it has been overcame, the hydrogen particles buddy up, joining and form into helium and releasing a lot of energy in the process. Now, to replicate this process on Earth, it's a little bit more complicated, but I'll not get into the details. I've bored you guys enough with physics. But I would like to note just one thing. We're at the stage where we're able to get more energy than we put in. Think of it like depositing $1 and getting 2 back, an investment. And fusion is the best investment you can make. It has all the potential for high returns and none of the downsides. Fusion doesn't emit any harmful toxins or greenhouse gases. If we're able to master fusion, it would be a significant step forward to combating the big bad wolf we call climate change. And to put into perspective how much energy we can truly get from fusion, just one nuclear fusion power plant could produce 4 million times more energy than burning oil or coal. Now, I'd like you guys to think back to the question I asked at the start about thinking of something useful. Would you consider nuclear fusion useful? Well, some of you guys said yes. But if some of you are still not convinced, I'd like to point out one more thing. What if I told you that the materials needed to create this gift is hidden in plain sight? What if we were looking out at sea right now, just in front of us? Would we think that the vast expanse of water in front of us could hold the key to such a gift? Well, it does. The main ingredient needed for a fusion reaction is found in abundance in our seawater. Not many of us would think that. Not many of us would just look out at sea and think it has such immense potential, but it does. And that's the beauty of our universe. Its immense power and potential is often hidden. It's in places where we don't expect. It's a reminder for us to appreciate and to look for the hidden gifts that surround us. At the heart of fusion, there's a never-ending dance of particles, the theater of the subatomic. The essence of our universe is in its ability to surprise us. Its most profound gifts and miracles don't unfold in the vast expanses of the galaxies, but in the minute realm of the subatomic. The brilliance of our sun, the potential of fusion energy, is all powered by these minuscule particles interacting and fusing. Think about that. The things that we just don't think about or we deem insignificant or just, it's just another physics lesson, have such potential. The purpose of this discussion and this speech is not to learn about the science behind fusion energy, but it's about embracing the philosophy it teaches us. The philosophy to observe, to appreciate, and to seek out the unexpected. Because the most potent gifts are often the ones that are hidden. Thank you.